Okay, so I'm going to be explaining 6a and 6b. These are kind of looking at Newton's second law as well, and we're also finding the magnitude of acceleration. But this free body diagram has two masses, so it has mass 1 and mass 2, unlike 5a and b. So first off, I drew my triangle. That's what was given to me. I drew mass 2, gravity, mass 1, gravity, and for this one it just goes downward, for this one it just also goes downward, but it goes downward on the opposite side of the triangle. So then I have my force normal going up on M1, and this is force normal M1g times cosine theta, and this is because it's adjacent to the right triangle, so adjacent to the value. And then we have my M1g sine theta value, which was found from M1g sine theta because it's opposite the right angle. So opposite right angle, and then we just use sine theta. So then I have my value that's given to me, which is 38 degrees. And so if there's a triangle here, these values are the same because that's from geometry where its opposite angles are congruent. And then we also have my new force normal. So we have our coefficient of friction going off of our M1g sine theta. So whenever you're doing these free body diagrams, it's just important to keep in mind what forces are acting on the graph, are acting on the masses. So for mine, I thought, okay, for M2, what's acting upon it? And I was like, okay, first, gravity. I labeled it M2 because it's only the mass, the gravitational pull on mass 2. And then for this one, I also said, okay, I know there's gravity and I know there's force normal because it's accelerating. So I put M1G because it's only M1. And so then I said, okay, I can draw my parallelogram to show that the forces are working together. So then I have N1G cosine theta because this is adjacent to the right angle. And so then I also added this because friction, pull. And so when I was just making this, I kind of thought in mind what forces are acting upon each thing. And so then in this direction, we have M1G sine theta because it's opposite our right angles. As you can see, this is a triangle. So it's opposite our right angle. So then, when I think about how I'm going to make an equation, I think, okay, Newton's second law. Sum of the forces equals mass times acceleration. And then if something's in motion, it stays in motion unless acted upon by a force. So for this, I have this and I have sum of my forces. So first I start off on the right hand side and I say, okay, M2G is the first force acting upon the block. Next, I subtract M1G because it's in the negative direction. So M1G is in the negative direction. This is also in the negative direction. So you have to think about, so this is whether it's going positive or whether it's going negative. So this is going the negative direction. So M1G is sine theta. And then I'm subtracting the coefficient of friction times M1 times this value. So times M1G cosine theta because I have to account for the force normal. So then I divide all of this by M2 plus M1 because it has to be the sum of the masses. So basically what I did is I just thought through, okay, I know it's force equals mass times acceleration because of Newton's second law. I know that it has to be divided by both masses because it's the total magnitude of acceleration of the whole block, both mass 1 and mass 2. And then I also thought about, okay, how does trig play into this equation? So I said, okay, I have my given value of 38 degrees, and then I just made my free body diagram thinking about which forces are going in which direction. So again, it's downwards negative, upwards positive. And again, I thought through, if it's opposite this, it's going to be cosine theta, or if it's adjacent, it's going to be cosine theta. And then if it's opposite, it's going to be sine theta. So for this one, it's opposite the right angle. So it's sine theta. And then this one, it's adjacent right here. See adjacent? So it's cosine theta. So then, moving on, after we found our equation, we just plugged in our given values. So super easy. If you have a good free body diagram, it's super easy to make an easy equation that's hard to comprehend, but hopefully I explained well. So basically, then I have m2 times gravity minus m1 times gravity times sine given value minus coefficient of sine friction, the coefficient of friction, times mass 1 times 9.8 times cosine 38. And then I divided this all by 3.9 equals 8.7. And then my conclusive answer was A equals 4.11 mass seconds squared. And I'm going to think about, okay, does this make sense? Did I make a free body diagram that replicates my acceleration? And I think yes, because a block that has these types of mass would typically be accelerating at a value around this size, just because it's dependent upon the given values. If it was a little too high, I would think my math would be wrong, but whenever I drew my free body diagram, I just thought through which forces are going in which direction, and then that just helped me find my acceleration. So, yeah. Thank you.